Welcome to Spring LIB.
This is the answer to Chapter 12, problem number 27 from the Smith Organic Chemistry textbook. And this problem asks us to draw the product of two Sharpless epoxidation reactions. And so I like the method that the book presents for trying to determine the correct stereochemistry for these Sharpless epoxidation products. So the book wants us to always draw the carbon-carbon double bond horizontal and to position the allylic alcohol to the top right of the alkene. And then if we redraw these this way, it sort of gives us a standard starting point. And if we're using the minus DET, we know that the oxygen will come from above. And if we're using the plus DET, we'll know that the oxygen will come from below. And so looking at A is already drawn in this configuration. So it's pretty straightforward. We're using the positive Sharpless reagent. And so the product here, the oxygen is going to come from below. So to start, we can draw our carbon-carbon bond with our epoxide in there. Okay, so there's that. And then we just need to fill in our pieces. So there's our allylic alcohol. Here's a methyl group over here. Here's the other methyl group on a wedge. And then we have a hydrogen on a wedge here as well. So pretty straightforward. And that's A. So then B, the molecule, the way that the problem gives us the molecule is not in this conformation. So all that we really have to do is redraw it so that it is in the correct conformation. So that's going to look like, if I could draw a straight line, that's going to look like this with our carbon-carbon double bond horizontal and our allylic alcohol to the top right. So there we go. And then for this part, for B, we are told to use the minus Sharpless. The minus tartrate reagent. But rather than redraw all those conditions, I'm just putting plus Sharpless or minus Sharpless. So with the negative version, the minus version, the oxygen comes from above. So here's our ring. Our ring is set into the plane there. And so since our ring is in the plane for this one, we'll put the oxygen coming out on wedges. And then we'll put our two substituents, so our one substituent and this hydrogen are going to be on dashes. So just like this. Okay, and so that's the answer to part B. So this is a straightforward problem if we use the method that the book promotes. So again, we're going to want to draw our allylic alcohols so that the carbon-carbon double bond is horizontal and the allylic alcohol itself is to the top right of the molecule. And then once we do that, we can apply these rules. So using the positive tartrate conditions, the oxygen will come from below. Using the minus Sharpless tartrate conditions, the oxygen will come from above. And so once we follow those rules, this problem becomes very straightforward. And that's the answer to Chapter 12, problem number 20.